This video will show how to use the elimination method or combination method for solving a system of linear equations. We have several options for solving a system of equations. One is to graph the two linear equations, which we can see the solution as a benefit, but the downside is unless it's an exact integer for the x and the y component, sometimes it's hard to tell the exact solution. Another method for solving a system of linear equations is to use the substitution method. A plus is that if the system looked like this, it's set up for replacing x with 3y from the first equation into the second equation so that we have an equation in one variable and can solve it quickly. That's the benefit. The downside of using substitution is that sometimes the equations are not easily solved for one variable and thus is time consuming. So let's take a look at a third option. The third method for solving a system of equations is called the elimination method, or sometimes it's referred to as the combination method. And it is based on the following principle. Our second equation has two quantities that are equal to one another. And using the addition principle, we're going to add the same quantity to both sides of the first equation. Although they aren't the same, these two quantities, 4x minus 3y and 17, are equal. So we are holding with the addition principle of adding the same quantity or equivalent quantity to both sides. When we do that, we will add like terms, which gives us a 6x. When we add the y's, you can see that they're additive inverses and they cancel one another out. And then adding the integers on the right-hand side, we end up with a substituted value of 30. This leaves us with an equation essentially in one variable, since 0y is 0 and added to 6x on the left side leaves us with 6x. By adding these two equations together, we now have one equation with one variable, which we can readily solve by dividing both sides by 6 and giving us a solution of x equal to 5. This is the x coordinate for the point of intersection, in other words, the common solution between these two linear equations. We next need to use that value of x that was found, plug it into either one of the two equations. We'll put it in the first equation, replacing 5 with x. We now can solve for the corresponding y value by simplifying the multiplication, subtracting 10 from each side, and to get y by itself, we'll divide both sides by 3. We now have our ordered pair and the point that is a solution to both of the equations at the same time. So again, here's how this works. The key is that when we add two equations together, we want to have one or the other of the variables to be opposite so that when they're added, they cancel one another out. So taking a look at this new system of linear equations, if we added these two together, we can see that we would end up with 3x and 6y. Neither one of the variables would cancel out. However, if we choose to pick on the y's, and by pick on the y's, look at a way of eliminating the y's, since they have the same numerical coefficient, all we would need is for one of them to be a -3 so that when added together they would cancel out. Using multiplication property of equality, this is pretty easy to achieve. We'll multiply every term in the second equation by -1, which will change each of those coefficients to the opposite of what they are. And now we're set up to use our elimination method by adding the same quantity to both sides of the first equation, combining like terms, we see that our y terms cancel out. 2x minus 1x leaves us with 1x, and a plus negative 7 is equal to 1 when we add like terms together of these two equations. So mission accomplished in terms of eliminating one of the variables by multiplying the second equation each and every term by a negative 1. We now know, because we have a solution for one of the variables, that these two equations do have a common point that satisfies both equations. We need to find the y coordinate. We'll substitute x equal 1 into either one of the two equations. We'll put it in the second equation and solve for y by subtracting 1 from each side, results in 3y equals 6. Divide both sides by 3, y is equal to 2, and gives us the solution then for these two linear equations, or this system, of 1, 2.